go on to Rebecca Nugent, and wrap up with Cathryn Carson. They've each been asked to talk for about 15 to 20 minutes, and after each panelist has finished their talk, we can have 1 minute of clarifying questions. And otherwise, I'd like to hold all of the remaining more open-ended questions to the discussion period after all three panelists have had a chance to speak. All right, we'll go over the coordination of how the discussion period works after we hear from the three panelists. So Nick, you're up. Thank you.
Great. Well, thank you very much, Deb, and thanks to the organizers. So far, it's really been a stimulating gathering. I thought that the human context and ethics conversation that just preceded this kind of builds very nicely in this question of how we can make transformational change at our institutions. And so I wanted to start a little bit from my perspective at Amherst College, and I'll talk a little bit about that, some historical sense, and also trying to kind of ground some of these conversations and other initiatives that have been happening at the national level. Rebecca and I served along with some other folks from Berkeley as part of the NSF-funded consensus report that was published by the National Academies in 2018, Data Science for Undergraduates, Opportunities and Options. And I'm going to be quoting from this because I think it has a lot of guidance, and it really mirrors a lot of the things and initiatives at Berkeley that we've been hearing about. A number of those are mentioned in the report. David Culler was one of the committee members, and there's been some other involvements from Deb, Ani, and others through those initiatives. But I thought that might be a nice place to get started. The report's available for free download at the nas.edu/envisioningds link. So in terms of consensus reports, these will typically come up with findings and recommendations. And obviously, no surprise to anyone who's here this week, recommendation 2.1 states that academic institutions should embrace data science as a vital new field that requires specifically tailored instruction delivered through majors and minors in data science, as well as the development of a cadre of faculty equipped to teach in this new field. And I think, again, that's a kind of a challenge for us all. We're kind of making that as we proceed and really trying to develop that as a kind of coherent new field. Recommendation 2.2 states that academic institutions should provide and evolve a range of educational pathways to prepare students for an array of data science roles in the workplace. This is also really what we had from the recordings and the office hours yesterday on thinking about the Data 8 course as a way of kind of providing data science across the curriculum, as well as the connector courses to tie in with other initiatives, and the Data 100 course to kind of provide a little bit more depth for those who are studying at a deeper level. The NASEM report talked about the importance of all undergraduates. Recommendation 2.3 stated that to prepare their graduates for this new data-driven era, academic institutions should encourage the development of a basic understanding of data science in all undergraduates. Again, building as one example, the Data 8 course, other things we could be thinking about. We heard a little bit from some of the ethics conversations before. What would a Joy of Data course or a data ethics course look like with a less technical focus to it? Finding 2.3 was a big part of the report. It talked about and defined this idea of data acumen. I kind of think of data acumen as being deeper than data literacy, and data acumen is only given by developed over repeated exposure to a number of related topics. These include mathematical, computational, and statistical foundations, a whole series of data technologies capacities, data management and curation, data description and visualization, modeling and assessment, workflow and reproducibility, aspects of career success factors like communication and teamwork, obviously the importance of domain-specific considerations, and ethical problem solving. And so when I think about my job at a liberal arts college and the mission to develop the liberal arts for our students, what could be more of a liberal art than the ability to extract meaning from data? And that, to me, is what has been motivated a lot of the work that I've been doing and a lot of the work that's been happening at Amherst College and other smaller institutions, as well as what we've been seeing at the R1s and other comprehensives. So let me give a quick introduction to Amherst College. It's an undergraduate-only institution with 1,850 students. They come from pretty much every state, 54 countries. It's about a 50-50 mix in terms of gender balance. 45% of our students are U.S. domestic students who self-identify as students of color. About 9% international students. 20% of our students are Pell Grant eligible. 11% are first generation. We're part of the 5 College Consortium. I'll talk a little bit more about that because I think these aspects of partnerships are really important when we think of transformational change. Amherst is just under 200 years old. We're going to be celebrating our bicentennial next year. We facetiously talk about the idea that we've been seeking truth through data since 1821, but I do think there's some merit to that. Obviously, when we think of data science, we often think of something that's been happening in recent decades, maybe early 60s, a lot in the last 10 years or so. But I think there's also kind of historical precursors to this through the liberal arts in various ways back into the 19th century. So kind of related to that, to some extent, the American Statistical Association is kind of the largest association of statisticians. It's celebrating its 181st birthday this year. And as you looked back in time, 175, 180 years, we can see the founders of the American Statistical Association. And these tended to be white males from Boston. But there was also a gentleman named Professor Edward Hitchcock. This was a geology professor who liked to count, who was an Amherst College professor. And I think kind of thinking about these kind of linkages of data science across the curriculum and how it connects in various ways, the precursors of some of the scientists who kind of got us started in some of these areas are important. So Hitchcock later became president of Amherst College. He's his picture given there. And one of the things he was famous for was the development of what we might think of as early dendrograms, kind of genetic relationships between plants as a way of representing kind of unstructured data in various ways. And so kind of thinking back to the kind of questions we want to answer, that we want students to be able to answer, and how that can be, the kind of things people have been doing in science and certainly in computer science, mathematics, and statistics in more recent decades. The National Candidate Report talked about the importance of ethics. Recommendation 2.4 stated that ethics is a topic that, given the nature of data science, students should learn and practice throughout their education. Academic institutions should ensure that ethics is woven into the data science curriculum from the beginning and throughout. I think the course that just got described from Santa Cruz on the ethics of algorithms was a kind of a neat way to think about how that can be embedded into a technical course with technical material and not just kind of like an add-on. At Amherst, we're also thinking about our history and how this relates to some of these questions. Edward Hitchcock's son was named Edward Hitchcock Jr. He was an Amherst graduate from the class of 1849. He later became a professor of hygiene and physical education, did a number of things in his career, but one of the things I think is notable and it's important for us to be thinking about was data collection in terms of his interest and efforts to promote the eugenicist movement. He was kind of very much into the philosophy that we could see differences between races, what he's describing here in terms of nationalities of individuals, and to kind of relate that to kind of the physiognomy, the measurements. And so here's a kind of an example of a data science problem used not for good purposes. And again, I think there's still work to be done to kind of see what was the rationale for this, how this proceeded, and to put that into that kind of context. And again, I think this brings up an example that hits close to home. What was the role of Amherst in terms of the spread of eugenics in this country? Other institutional transformations are happening at many small colleges where we're just one, and I just wanted to give some examples. We developed a new statistics major that has a lot of components of data science as part of those capacities beginning in 2015. We now have a set of new data science electives that are being offered by both statistics and computer science faculty across the college. We have a new capstone course and then multiple introductory data science courses, one taught in statistics, another taught in astronomy. There's now an increased focus on data wrangling, ethics, and communication in many of our courses, pretty much all the statistics ones and many of the computer science courses. We've developed a new non-major course on statistical ethics, as well as a number of co-curricular initiatives I'll talk briefly about, DataFest and the SDS Fellows. We're organizing all of this through a faculty coordinating committee and kind of try to build other curricular connections and kind of make the interdisciplinary aspects of data science real. Kind of an example of how this is working, Emily Dickinson, local Amherst poet, the Emily Dickinson Museum is part of Amherst College. And so we take full advantage of the fact that it's just down the street from us. We've had students engage in various ways with their poetry. They're going to go off and do various text analytics type things in the future. Let's kind of have them kind of develop some domain knowledge and some context in terms of poetry, and to kind of build digital humanities and some other kind of literary text analytics approaches. Again, similar to what we saw in the Data 8 presentation, where they're kind of doing some literary analysis of Little Women. Same kind of thing students can be doing, kind of just engaging in various ways. Take them to the museum, kind of after doing some reading, develop that context, kind of allow them to be in Emily Dickinson's bedroom, and then kind of take from that kind of what could we try to extract, what kind of meaning, what kind of relationships are there. Again, for many of the students, first time they've been to the museum, first time starting to think about text as data, I think it provides lots of opportunities for us to kind of engage, not just in our computer science and statistics departments. The ASA has been organizing its Data Fest. It's this weekend-long data challenge. We've been coordinating this in our area through the 5 College Consortium that I mentioned previously. Data Fest we have in early April. Typically in New England, we'll get some snow during that time. Doesn't deter the students. You know, these teams of undergraduates, we have about 125 of them from the 5 schools, will work around the clock to find and share meaning in a large, rich, and complex data set. It's a neat environment. There are roving consultants, graduate students, faculty, and industry professionals are providing assistance. This was founded at UCLA in 2011. There are now dozens of sites with thousands of students all over the country. Just to give you some idea of this, 2019's data were from the Canadian National Women's Rugby Team. Each of the players had little GPS and the various other training information available to look at the role of fatigue and workload. 2017, there was data from Expedia on kind of what was predictive of hotel bookings or not. Again, feed the students is really important part of that. But again, building community, making these connections. Students have a serious side to them. There's also a playful side to them. But again, kind of this ability to kind of apply what they've been learning in the classrooms in other ways. We've been working in Amherst on other kind of connections across the curriculum. We have a pilot project for the last couple of years with our quantitative center to develop modules. So we have faculty in computer science or statistics develop modules for courses that have quantitative and computational components. So we have developed a module of the death penalty for a law and jurisprudence professor. We kind of help develop, administer, and analyze surveys with a political science professor. And kind of a music analytics project took place in a harmony and counterpoint course. Again, the idea is to kind of build that capacity in the same ways that the army of students coming out of Data 8 have kind of made connections in other realms that allow kind of the faculty in those areas to start to kind of upskill and kind of see what's possible. We've developed something called the Statistics and Data Science Fellows Program. So these are undergraduate students. So we have this cohort of about 10 of them to address data challenges across the campus. So they provide drop-in hours for intro stats, data science courses. They organize kind of events, this festival of our Markdown, getting people kind of started for the semester, doing workshops leading up to Data Fest, and conducting data-related projects. And again, this is something we've structured under the direction of their statistics faculty as a way of kind of providing these connections to other students, staff, and faculty at the college. Technological support for transformation is critical. We saw a lot of that in the recordings and the office hours yesterday. We share this philosophy of the Data 8 that, you know, having campus-wide RStudio and Jupyter Hub servers will facilitate the teaching of courses. Just bring your own browser model really does kind of reduce barriers in really important ways. We've also developed a series of GitHub organizations for course development, resource sharing, related projects. We've used Slack, Piazza, Gradescope, and related technologies to foster engagement. And again, having this swarm of STS fellows who we can tag onto undergraduate theses and faculty research projects or other kind of staff projects has been really helpful to kind of build the capacity to extract meaning from data. Diversity and inclusion is really important. The NASEM report described that data science will benefit from broad participation, and also that as data science programs develop, they need to focus on attracting students with varied backgrounds and degrees of preparation and preparing for them for success. We were able to host the ASA StatFest at Amherst. This is a one-day conference for historically underrepresented students in statistics and data science. Fernanda Perez was one of our keynote speakers, which just brought together a set of students, the next generation, to kind of see what opportunities there are in this area, to kind of really make much more transparent what may not be so obvious to them in other ways. The National Academy's consensus report talked about the importance of dialogue between institutions. Again, I think this workshop helps with that in a lot of ways. Recommendation 3.1 states that 4-year and 2-year institutions should establish a forum for dialogue across institutions on all aspects of data science education, training, and workforce development. A lot of ways this is happening. I wanted to talk about one specific one. Amherst, along with our 5 college colleagues and some other institutions, community colleges in the area, have an NSF grant to do data science for social good. And so the first goal here is to develop authentic hands-on experiences for data science students. And then second is to address the need for data science among local organizations, build the capacity and the kind of the workforce opportunities there. So we have teams of undergraduate students wrangling, analyzing, and visualizing data from community organizations using agile data science methodologies. More information is available at the URL below. It's been pretty exciting to think about how we can boost these opportunities for these sophomores as part of their kind of development of data acumen. It's also been really, neat. There's a lot of work to be done to kind of see how this would kind of play out at community college level. How can we be bringing in students who are getting their associates, perhaps transferring to one of our institutions? So, kind of bumping back up from Amherst, kind of thinking a little bit more high level, I think the big questions for the panel, what I'm hoping to do in terms of transformational things that are going on, is how do we build connections? How do we broaden our efforts? And how do we foster this kind of transformational change? So I just want to talk about a couple of other related initiatives. The National Academies also organized a roundtable on data science post-secondary education. Deb was a member of this, and a number of other kind of participants at the workshop today. The roundtable was a 3-year initiative to kind of raise all kinds of interesting questions, to bring together noted people from government, academia, and industry, and talk about a number of topics that were relevant. And so the URL here, the nas.edu/DSERT, includes narrative summaries of each one of those 12 meetings. Those notes, I think, are still kind of chock full of great ideas, particularly for these questions of how to make change. There's kind of a session on 2-year colleges, coordination between academia and industry, motivating data science for social good, aspects of inclusion, aspects of reproducibility, ethical and privacy concerns, and many others. And again, so if you haven't looked at those, they've been recently collated together as well. There's a lot of good ideas there, particularly for smaller schools on a number of those meetings. There was also the NSF-funded two-year college data science summit that provided recommendations for two-year colleges. Many schools are now developing data science programs. I'm looking forward to the panel that we have this week. But again, they typically fall into three categories. You're seeking employment after completing an associate's degree, to think about the transferring to four-year programs, or for pretty much every institution, developing certificate programs and courses for professional development. Last but not least, I wanted to kind of give a shout out to the Academic Data Science Alliance. They have a goal of building community, and they think of that very broadly, of academic data science leaders, practitioners, and educators, as well as what they call academic adjacent colleagues, to thoughtfully integrate data science best practices in higher ed. So this grew out of the more Sloan data science environments, and I think as a result has a creative and nimble approach, which has been really pretty exciting. They have an annual conference, but also special interest groups on ethics, education, and diversity and inclusion. So kind of closing questions that I'm curious about and kind of think about in terms of what's going on locally, what's going on in terms of our networks and going on nationally. How do we facilitate data science for everyone, given the staffing constraints that we're seeing? How do we create these opportunities for faculty development and build connections across campus? Are there ways to better share resources, approaches, and best practices? Can we develop integrated data science majors, even if we're not nearly as large as Berkeley and its new innovative program? Can we develop additional pathways through minors or those who want just to dabble? How can we make these opportunities for students more transparent? And at the end of the day, how do we assess that we're actually doing what we say we're doing? So I'm looking forward to the other conversations, Rebecca and Cathryn, take it from there. Thanks.
Thank you so much, Nick. That was great. We do have 1 minute. If anyone has a clarifying question they'd like to ask before we ask Rebecca to speak. If you do, can you please type your question in the chat, and we'll be monitoring the chat. I'll give you 5 seconds to say, I've got a question, and then we'll switch over to Rebecca. Looks like we'll wait till the end to continue the conversation, but that was a huge amount of information, Nick. Thank you. And there's a question. Is the ADSA becoming the consensus organization? Like the ASA for stats, MAA for math ed. Nick, is that something you think you could answer in 15 seconds?
I think they complement the other associations in some really good ways. And I think this question of like, what is the best structure to bring together some of these connections? So I think that ADSA certainly is doing some pretty innovative things, which is why I gave the shout out to it.
Great, thanks. All right, next up we'll have Rebecca. The floor is yours, Rebecca.
All right, thank you very much. Can you see my slides okay?
Yes.
Excellent. Let's do some full screen here. Well, let's make, actually, I'm gonna flip back and forth, so I think I'll just leave it there. So thank you so much for inviting Carnegie Mellon to this institutional transformation panel. Oh no, come back, there we are. Thank you so much for inviting us. We are super happy to learn from this community. I think that we're all kind of in this together, so to speak. And anytime that we can come together at these types of data science education workshops or some of the other meetings that Nick was just talking about, I think that's a real benefit. And the more that we're open about the challenges and the struggles or ideas that we have, the more that we're all going to benefit as a group. So what I'm starting here with is data science of view. And this is a graphic that comes from Jeanette Wing's recent article in the Harvard Data Science Review. It's a great graph that shows kind of how we're thinking about taking disparate data sources or questions from all kinds of things. We have people, we have servers, etc. We're going through this generation collection process, storage, management, etc. If your students are anything like my students, they think it's all just in the analysis category. thinking about visualization as well, interpretation. At the end, we're back to people. So one of the things that I always find interesting about this is that when I'm talking to partners and outside organizations outside of academia, people who are interested in shoring up their data science capability, they think it looks like this, that it's some kind of smooth process. And the reality is much more like this. So for those of you who are old enough to remember Choose Your Own Adventure books, this is really kind of a world where you open up a book, it tells you, you have a choice. You can either go into the cave or you can run on the beach to get away from a bear or something. And then you go choose, and it tells you to go to page 12 or page 20. And you choose page 12, you go into that choice, and you find at the end, you know, that your lantern broke and now you've died. So then you think, oh, that didn't work out so well. Let's go back and let's try the other option. Let's go to page 16 or what have you. And I think that the data analysis workflow actually looks an awful lot more like a choose your own adventure diagram, which is what you see here to the right from Edward Packard's first Choose Your Own Adventure book. And what I mean by that is, you know, it's not this like going from one phase to the next. There's iterations and loops, and you try things and it doesn't work. And then a new team member comes in. You have to catch them up, and you inherit someone's old floppy disk from 1982. And you're like, how on earth am I going to integrate this data? It's really, really messy. And it's very, very difficult to teach. It's very difficult to do. It's very difficult to build a program on it. And it's very difficult to transform an institution with respect to data science. So if you are struggling with any of these, you are certainly not alone. So what we're thinking about at Carnegie Mellon, and I'll talk a little bit more about some of the projects that we're doing, but what I'd like to start with is this idea that data science and the reality, it starts with people and it ends with people. So everyone is interacting with data, but they're not necessarily coding. And I'm not talking about at a university. I mean everyone, people K through 12, people who finish school. Everyone is interacting with data and information all the time, but they're not necessarily coding or what we think of as programming. And that we need to make sure we don't lose sight of data acumen in a rush to teach programming, because many people will never program ever. Cathryn is going to talk a lot about what's happening with Data 8, and I know you've already heard about this week, which is an amazing program. I love it. I'm just trying to draw a little bit of attention to the people who aren't going to program. The other thing that's been coming up a lot, especially at our university, is who really owns data science, like who's in charge of teaching data science, who gets to do data science. My own personal opinion is that we all get to do it. So we've been trying to build platforms and programs that anybody can participate in, not just people who are going to get degrees in data science and the like. The other thing that's coming up all the time in most of our programs is that if the work isn't understandable or it isn't communicated very well, it doesn't really matter how good your team's technical skills are. Our students are stunned regularly when they're working with outside partners about how they want to show some incredibly beautiful, complex algorithm that has wonderful prediction values and has all of these, there are all these technical discussion behind it. And if the outside partner doesn't understand it, or if the results aren't able to be interpreted, they don't use it. They just simply will not use the material. And so I think having that understanding of how data science is used in the real world is really useful for any program that's being built. Similarly, if people just choose to Google, like if we have high school students who are thinking about going to a 2-year college, 4-year college, what have you, and they Google data science education because they're trying to figure out if they want to study this, they're going to see a lot of links and opportunities that are associated with very technical things, courses, technical languages, packages, tools. And that can be very misleading because it dominates in the advertising of what data science is. And it also is intimidating. And students self-select, right? They take themselves out of the running. They think that can't be me. I can't possibly do this. So we need to be thinking about how we advertise data science to our larger communities, both local, national, international, et cetera. Because without communication, collaboration, and the emphasis on context, this data science goes absolutely nowhere. Okay, so So we are doing similar things to what Nick is talking about at Amherst with respect to workshops and programming and courses, and similar things to what Cathryn's going to talk about at Berkeley. So what I'm doing with my 15 minutes is highlighting a couple of initiatives that are outside of just what you would typically think about a data science program putting together courses, but I'm happy to answer questions about that as well. I just want to highlight some different things you might be thinking about when you think about using data science to transform your institution. So just for a little bit of context, Carnegie Mellon is a private university in Pittsburgh. We are about 7,000 undergrads, 7,000 grads. That close to 50-50 split actually makes for a really interesting culture on campus. Research is very highly emphasized, but education is as well. So you'll see a lot of people trying to align research and education into the classroom. Like they try to do things that overlap quite a bit. We have these 7 colleges: Fine Arts, Engineering, Hines College of Information Systems and Public Policy. That's largely a graduate program. Mellon College of Science, Computer Science, Business, and then we are in Statistics and Data Sciences inside the Dietrich College of Humanities and Social Sciences. The next bullet I have there is just to give you an idea of the diversity that you see within colleges. Carnegie Mellon is very decentralized. It's really interdisciplinary. It's a little bit quirky. And the list that you see starting with Center for the Neural Basis of Cognition, those are the programs that are inside the Dietrich College of Humanities and Social Sciences. So just to give you a flavor of how different these groups are that then need to work together on their courses. We also have at the graduate level people doing data science in Hines College, the Block Center for Technology and Society. We have degree programs related to data science in the School of Computer Science, the Mellon College of Science. It's kind of all over the place. Within our program, of those 7,000 undergrads, about 550, 600 of them are in our department. They are majoring in stat, math stat, stat neuro, econ stat, and our most popular degree is statistics and machine learning, which is joint with the machine learning department in the School of Computer Science. So the reason I have this on here is to note that there are no degrees that say data science in them. No degree at all. There are a couple of master's degrees that do, but there's no undergraduate degree that says like a minor in data science or a major in data science. The department has data science in the title, and there are people doing data science, but there's not just, for example, an institute or a center, et cetera, or a degree. But almost all of the statistics and data science courses across campus, from freshman level through advanced PhD, are in the hundreds of students. We don't really have small classes. Even our PhD statistical theory class, which Lord knows why anyone would take that for fun, but the PhD statistical theory class can get 300 people in it. So it's kind of a weird circumstance. Okay, so what have we been doing and changing? And then I'll highlight a couple of programs. We have been, as I said, we don't really have undergraduate degrees where it's just the title is data science. Instead, across the campus, you see an increase in data-centric skills in all of our courses and programs. This includes doing freshman level data discovery courses that are sort of along the lines of aiming for a general education requirement, all the way through very technical skills that you might see in more advanced courses. We do have 9 to 10 different master's degrees in data science. I say 9 to 10 because some are in development. They are all data science kind of with some like different flavor, so to speak. So we have data science and public policy, security, statistical practice, things with an artificial intelligence flavor, just very different things. But the campus is very strongly focused on the interaction between people and data. And the phrase that we use is the nexus of humanity and technology. And that's where kind of a big thrust of our several campus-wide initiatives is moving. That it's not just about learning about how to technically work with data. It's the fact that people are going to be doing this. People will make behavioral decisions. People will take the results of data science and make decisions with them, et cetera. So the types of degrees that you see forming are things that incorporate a lot of that people data flavor. So for example, behavioral economics. We have a new artificial intelligence degree that has many courses that are not in the School of Computer Science. So things are very interdisciplinary where we are in Pittsburgh. They have developed some fifth-year programs that are designed for the undergrads. I can answer more questions about that if people want. But there's been a big push on the campus for the next two things: experiential learning, and then this idea of how to build data acumen, which is taking the kind of the form of doing some analytics platforms and online learning, how to build data acumen for a broad audience. And one thing I want to highlight is what we did not do, because many universities in the first sort of boom of data science, their provost or their board of trustees, et cetera, authorized cluster hiring of, say, many data science faculty lines. And we saw that across the country. And I think what some of those institutions ran into is, what do you do after you hire all those faculty? I mean, getting new faculty lines is great, but what's kind of the next phase of that? We did not do that at Carnegie Mellon. We did not cluster hire or bring in a huge number of faculty associated with data science. We just kept looking for interdisciplinary people like we kind of always would. I just wanted to float that you don't have to do that to change your institution. You don't have to cluster hire a big group of data science faculty. Okay, so very briefly, two initiatives to highlight. One is data science experiential learning. This is happening across the campus. We are up to, across the campus, experiential learning is up to about 300 projects a year where students collaborate with outside partners. Within data science, we hit anywhere from, I think we do about 30-ish a year now, 30 data science collaborations with outside partners. And these are very complicated real-world data science problems. They can be from industry, for-profit, nonprofit, social services, government organizations. It could be clients on campus. And they bring them and they actually do them as part of their coursework. So we match teams of PhDs, masters, and undergrads to these projects. The students get faculty supervision. The legalities are covered under something called an educational project agreement. And we work with startups that are 6 people all the way through global Fortune 100 companies. If you want to get a sense of the types of projects that we do, you can go to the website that's at the bottom of this slide, stat.cmu.edu/capstone research. And that'll give you an idea of what happened last semester at the undergrad level. So that's not including the PhD and master's, that's just the undergrad level. But what you'll see is a really, really diverse set of projects where students were able to interact with real data science problems. I mean, they were given incredibly messy stuff. This is certainly not Excel spreadsheets, although sometimes there's Excel spreadsheets, but you know, text data, network data, image data, things that were super messy. And the students were often very surprised at how, 80% of any data science problem is actually just figuring out the data. It was good for them. The projects tend to be really diverse. We have a huge group of students working right now on COVID forecasting and nowcasting. We had some experience in the past doing flu, and so now we're working on COVID. We've done things with supply chains, hedge funds, real estate, injury rates, construction companies, publishing houses like book publishing. We've done stuff with Tinder for brands. We've matched celebrities. We do an awful lot with sports analytics. So it's very diverse is the point. The lessons that I'd like to highlight here is that to do this, and I'm happy to answer questions from anybody who's interested in starting one of these programs at their own institution, the lessons learned here are that you really need a very close partnership with the business engagement or corporate relations or advancement offices, whatever they're called on your campus. They are really, really helpful in identifying potential partners, helping you scope the legal documents, helping you scope the projects, et cetera. Alumni who finished and are now off in their own companies love being able to participate. So you have an entire pool of people that you can go ask, hey, are you interested in having a project come and be part of our curriculum? I would start extremely early on legal and intellectual property review. I'm happy to answer some lessons learned there because that's very complicated. And you should start very small. Do not try to launch a program with 20 projects all at once. It is incredibly difficult. But the other lessons that the students have been learning from this type of program is that the upstream tasks on that data science lifecycle have a really large effect on the results from those algorithm and analysis stage. And that when they spend their time on those upstream tasks and think more about their questions, their work is much better, the results are much more usable, etc. And that they should be thinking much more about the data, and to get away from the idea of building incredibly complex AI ML models. They don't actually need them at all. More robust and simpler is better. But over and over again, we see that it's the people, the impact, the decisions that people make about their data, their variables, how they integrate things, what they choose to store, how they choose to store it. The downstream impact of all of those is pretty non-trivial. So we've been trying to help people better understand how people interact with data science. And then I was in this panel a few weeks ago in SDSS. And one of the speakers had this incredible, I can't remember the name of the person that she was quoting, but it's this idea that this isn't data-driven decision-making, it's data-informed decision-making. We're not getting rid of the people in data science, we're helping people make data-informed decisions. Okay, the other things that we're doing on our campus kind of fall into the category of trying to figure out how to make data science belong to everyone, and that it is not something that divides us into the haves and have-nots, but that it's more something that can unite us. So that some of the programs that we've been thinking about are how to do intro to data science workshops for fields that you would not expect to be doing data science. So that's a little bit of Data 8 flavor in there. Trying to build a data science community core network, thinking about our local communities, bringing in projects from our local businesses, and trying to have that spread across the campus. We do quite a bit in sports analytics, and I bring it up because it's a growing field, but also bring it up because sports for some populations, particularly younger populations, is a really natural way to start thinking about data. I'm thinking really young populations. So if you're thinking about building outreach programs to K to 12, things like sports, things like applications with public policy, community-driven questions, those are all big hits in the K-12 community. They're interested in what's happening around them in their local communities, and some of them are also interested in what's happening with sports. And we do quite a bit of diversity, equity, inclusion work on all of these summer research programs. The other thing that we participate in is Women in Data Science. This is a set of, we're up to a few hundred events that happen across 6 continents. So if you just Google WIDS, Women in Data Science, you'll get the website that's affiliated with this. The speakers are self-identified female, but anybody can go to the events. So I highly recommend maybe looking up the one that's near you, or if there's not one, just start your own. And we're trying to work on thinking about data science for everyone. So the last thing that I want to show you is one of the kind of our technical solutions for this. And the goal of this aisle thing that I'm going to show is really, how can we get data science to be accessible to a larger, broader, more diverse community? But then how can we also understand and help people do data science that's not just about how to code or program, that it's about how to work together, how to communicate, how to be on a data science team. Those things are really, really hard to teach. And of course, you keep practicing, you get better, but we don't really have a good sense of how to best teach that. And so that's one of the things that we're trying to do. So this aisle system that I'll just flash through here, these are browser-based platforms that anybody can use. They're interactive, and they allow us to kind of watch people do data science. So I'm not going to go to this website just because I don't want to click out of the Teams and cause problems, but or click the windows here. But if you go to stat.cmu.edu/aisle, you'll see a huge website that has lots of examples of, it's this educational platform that allows us to kind of track and research how people are doing data science. You do not have to use this for statistics and data science. We have it used in classes that aren't in our department. It allows you to do Sketchpad, you can flip your classroom, you can do, there's video chatting, audio chatting, it's just like Zoom, you can do all kinds of stuff. But we also have data explorers, reports, and presentations. The students can talk to each other, they can share their work, they can do group data analysis activities, and while we're watching, so to speak. So who's using this and what are we learning from it? So the hundreds of students at Carnegie Mellon at the undergraduate and graduate level are in aisle, but other universities are using it as well, particularly given our current COVID-19 remote situation. We have lots of universities reaching out to start using it for this fall. So please feel free to let me know if you're interested. Like I said, it's not just statistics and data science classes, English, biology, etc. But we're analyzing how people write. We're trying to build remote learning for data science. We're trying to build adaptive pathways where if people start to work on one project and miss a couple of questions, then the material, the platform adapts and shows them other material that might help them review and get back to where they are. And the thing that we're very excited about that we're working on right now is we are able to do collaborative data analysis. And so the link that's on the slides right now, which I'll put in the chat after we get out of this shared window, is an example of how people can collaborate on work. So you're welcome to go to that and start typing around if you look. But students can work together in a web browser, writing a report, building a data analysis, talking to each other on chat, and we're tracking what they're doing. And what we're learning is how to optimize how these students and people can work together on data science so that we can teach them better, so that we can make suggestions, so that we can not always be horrified that everybody's all doing their report at 4 o'clock in the morning, you know, that kind of thing. But we can tailor our instruction. So feel free to take a look at that. And our takeaways on that initiative is that we really should not just be thinking about building data science courses and programs, that we should be really thinking about, like, why do people do data science? How do they do it? How do we research that? And that we need to teach people how to do it together. We need to build accessible tools for non-STEM communities. We're seeing a lot of diversity in thought about data, not that people are thinking incorrectly about data, but they're just thinking differently. And that we're going to need software and platforms that allow for customization without requiring background. So if we're going to get students early, let's say in the K-12 space, to move into two-year schools and four-year schools and support them as they transition into more coding and more programming, we're going to need software and platforms that allow them to do that. And the last point I want to make is something we've been really thinking a lot about, my team, the last few months, is what happens with infrastructure and accessibility. For example, we give everybody all of these tools. What happens when we're all remote and someone's internet goes out? What happens if they don't have the financial resources to have internet? What happens when there's just incredible access issues with respect to the technical tools that we're giving people? So whatever we design, whatever programs, courses, tools, packages, whatever we do, we need to be able to think about how could anybody do this in any circumstance, and that's incredibly hard. So I'd love to hear thoughts from the community on that as well. All right, thank you very much.
Thank you, Rebecca.
Stop. Yeah. All right, great.
I think in the interest of time, let's switch over and get Cathryn started.
Yeah, sure.
Her talk. And Matthew, Brett, we'll hold your question for later. Thank you for asking it.
I can also do a little bit in the chat. But I'd love to hear Cathryn's Data 8 story.
Okay.
So can you guys hear me?
Yes, we can.
Okay, so I'm having some echoes, but if you're not, then I'll just go ahead and forgive me.
No echoes here.
So I get the privilege of speaking about institutional transformation from the perspective of Berkeley's data science education program and the Division of Computing Data Science and Society. As Deb Nolan mentioned, I'm a faculty member here at Berkeley. I'm formerly the Associate Dean for Strategy and Planning and our Division of Computing, Data Science, and Society. And I've been lucky enough to be an ongoing institutional steward of this transformation at Berkeley. Briefly, I led or co-led both of our campus level design committees starting back in 2014, both for the undergraduate curriculum and for the new division. I got to stay with the undergraduate program as faculty lead for most of that time, and I also got to co-design and co-teach one of the backbone courses, Data 104. So I get to speak here on behalf of that whole collectivity of faculty and staff and students who have carried it over the years, and hoping that that experience, though it's like, yeah, quite distinctive to Berkeley, will be useful to others. Everyone has their own institutional settings, but there are some common lessons, and I'm going to try to bring them out here and open it up for conversation. So the theme is transformation, institutional transformation, and I want to start with stories of people. A student story, Ian Castro, who came to Berkeley without any intention of studying data science, is majoring in biology and media studies and was just totally drawn in by Data 8, Foundation of Data Science. It may be that we transformed his life. He also transformed ours because he dug into helping other students, helping professors across the curriculum, and bringing in other students who may not have identified with data science from the start, but found their place in it. So transformation is bidirectional. It's a student story and a faculty story. Victoria Robinson directs our American Cultures program, which looks at race and American society across the campus. And she came to us and said, you know, it's great that you've got Data 8. That's lovely. I'm glad you got to teach it to me. But what I need in my class on detention and immigration is a way to engage my own students who are potentially distrustful of your methods, who want to understand the phenomenon underneath, not the methods for their own sake. In her case, prison overcrowding in California. She's been working with us now over multiple generations of students who have taken her class, come back and taught in it. She has taught us so much about data science in the world. And so I start with these stories because they give us a pointer into our challenge here at Berkeley. This is our world, the one that Ian lives in, the one that Victoria lives in. How do we build a data science program adequate to it? This is something more ambitious than building a data science undergraduate program. I called it institutional transformation. And why is that? If you start from the world around us, rather than the disciplines, the world that drives the students into Data 8 and the classes that build on it and the modules that surround it, if you start from that world, the datafied world that we live in, where we put out signals and data about us is collected, data about human phenomena as well as natural phenomena, when we work on it with machine learning algorithms and do classification and prediction, and then put it to work across every part of our social order, changing our world day by day. If this is the world that we live in, then we need critical data science capacity across society and across the workforce, because data science is transforming the human world. And that means we need a new strand in educating our students in a more holistic and sometimes pretty challenging way. So what could I mean by that? Our observation is that yes, data science definitely has a history in existing disciplines, but it is something new out there in the world that is transforming it daily. It's not just another technical major added in among others. We have it as a broad base to our education. At Berkeley, we see how very broad this need is. But it is also a human science and a social science, just as much as it's a natural science. It is not just a STEM field. And it is coming in at a time when the education that students need across the university can't be limited to STEM approaches. What we're seeing today around data science, I think we can say, is something comparable to, what Cold War national governments invested in STEM training back in the 1950s, 60s, 70s. but broader, potentially more empowering, hopefully more conscious of its consequences, aspirationally more democratic, and at scale, happening fast, happening in real time with us. And we have to manage this. So how do you work in this situation? How do you manage an institutional transformation in real time? It doesn't start from looking inward at higher ed's established structures. It starts from looking outward at that change in the world. And the question for us is not just like, how do you get a program stood up inside our institutional frameworks, though we have to do that. It's how do you do it right? How do you get the right architecture and values? How do you get the right people at the table? How do you get it so it meets the needs in the world and can adapt as that world changes semester by semester? And how do we meet the needs of our students, which is why we're here. So how do you manage an institutional transformation in higher education? You start by recognizing that that's what you're doing and taking some cues and concepts from theories of change and I'll say analyses of social movements, because data science done right changes the institution that hosts it, which makes it even more significant to do well. So if institutional transformation is the goal, then it's more than just the stacking of statistics and computer science or some subset of that union plus domain areas stacked on top of it. We need more complex thinking than that. The world is teaching us that these disciplines are fusing and being reconfigured. And so you might think of the design challenge as actually starting from the domains where data science is used as integral. This is where student interest most commonly starts, whether it's K through 12 or higher ed. And each different discipline or each area of student interest brings its own questions and frameworks. And so I've outlined here some of the modules offerings that we did in the first semester when we worked with Victoria Robinson with her ethnic studies class. You meet these instructors and these students where they are on their own terms. And then you find different institutional ways to serve them and channel them. Modules, connector courses to Data 8. We're now doing a kind of on-ramp to Data 8 that we'll call Data 6, which starts from social sciences and teaches computational thinking through engaging with the social world. It goes up and down the curriculum. And we see that it's also part of student discovery projects. What we're seeing in most of our honors theses is engaging with the application domains in a full-throated way, respecting the instructors and the students' categories, their methodological stances, and going beyond just giving them data science skills, because we gain so much from that encounter. At the same time, we begin with fusing computation and inference and making it broadly available and accessible so that students want to engage. And so, you know, in Data 8, you see just how elegantly statistical concepts emerge when you're working through computing on data. The example here that you have is American jury selection, random selection, and bias. And up and down the program this week, you can hear more about Data 8 and Data 100. They're absolutely foundational to what we do, teaching computing and inference together by looking at that real data. This is a fusion of statistics and computer science that makes both of them look different, and these disciplines we are seeing are reconfiguring in real time. So third area is bringing in fully human context and ethics. That's the Berkeley larger category than ethics that we've decided to work with, which makes data science responsive to the demands of the day and of the world. It's part of what we feel our students need to learn, whether it's in the major or in the minor, or in the student discovery projects, or in our internship courses. We want to put into everything that we do. And we speak about this happening in two ways. One, we say we have dedicated courses. We prefer that to the term standalone because it points to the expertise that the faculty in those areas in the humanities and the social sciences bring to the program. And then we talk about integrated. It's kind of the flip side of modules in humanities and social science courses is bringing in social scientific and humanistic content into technical courses. And we think it's important to do both as far as we can. So what these areas do is provide the kind of interpretive and analytical toolkits from the social sciences and the humanities and teach students how to wield them, to understand power, to understand representation and classification and the ways we co-construct technical systems in a social world, to understand things and then to put those tools to work in shaping the world that they want to see. Faculty from that part of the university, this is what they do in the social sciences and humanities. And so we've invested in the dual approach that makes them feel like full-fledged partners. It's not a simple thing because social scientists and humanists have some pretty sharp tools for thinking about everything from what privacy and ownership means to systemic racism and the eugenic history of statistics, to the narrative of Silicon Valley. We've decided to take on that work in part because human context and ethics aligns very strongly with Berkeley's values, and it's been important for us to make it integral to our work from the start. So we've been exploring ways to take this a little further as well. We're developing yet another on-ramp to data aid that's an American cultures course, which deals explicitly with race in American society under the heading of data and justice. We're exploring ways to bring in framings like participatory action research, which those of you who work in professional schools of education or social work or public health may recognize as a kind of community engaged scholarship for our students to experience. And then I can speak later at the end if it's interesting around why we chose the framing of human context and ethics rather than some of the others that are out there. That was a deliberate choice that has some meanings for us. Okay, so you build on this in order to start more adequately addressing equity and inclusion. That's our aspiration in the program, in a way that not just engages with technical questions as critical as they are in data science and algorithms, but truly recognizes the life experiences in the world that our students bring in with them. When they walk into a data science classroom and hear about algorithmic reproduction of bias in the criminal justice system, or facial recognition tech and how it's used by police, or the construction of the categories that we collect census data in. Having concepts like justice and privilege at our disposal, that kind of representation and pointed discussion of difference makes for better and more societally aware, more socially reflective data science. So this is something that is a deeply challenging move in the framework of classical STEM education. We see it as broadening it and adding a new dimension to it. And we see that one of the opportunities for data science is to recognize that it is not just a technical field, that if it's about data and human beings, as Rebecca and Nick were saying, then it is a human and a social science, and we need those categories and those challenging conversations in our data science program. And finally, a fifth dimension for Berkeley has been from the start, how do you put those tools and responsibility and power in the hands of our students? And you've seen them show up, in every part of our program that you've had the chance to hear about. They develop course content, they reach out to other students and instructors, they're deeply involved in offering this workshop. I mean, everywhere, up and down across the program. And how you do that, in part, is by recognizing that they are agents in their own education, as Sophia Noble said so eloquently in the HCE panel this morning. And we're working with them, giving them power, learning with them along the way, and giving them the capacity to feel like agents in their own education. Something that I know all of us who are educators are deeply invested in. So on this trajectory, if we start, the clock sort of arbitrarily back in 2014, when our campus put together a data science education rapid action team, in the 6 years since then, almost literally 6 years since then, I'd say, this is Cathryn's personal estimate, we're about 60–70% of the way of engaging application domains, in part because we started pretty strongly there, in part thanks to the Moore Sloan Data Science Environments program. We've made considerable headway, though Deb and the Data 8 and 100 faculty can tell me that we have even more to do on fusing computing and inference, but I'm just awed at the work that our faculty in those disciplines have done to pull together a new conceptual framework. On human context and ethics, there's so much more to do, and that's inspiring as well as it's challenging. On equity and inclusion, we're not nearly as far as we'd like to be, and here Berkeley has a lot to learn from others in this workshop. That is, it's profoundly aspirational for us, and higher education is in a process of changing, and Berkeley is not always up the front end of it. We do feel some feeling of reassurance, though, that our students are coming out into their worlds and their lives feeling empowered through the experience that they gained in the program. And what we take away from this is that institutional change is a long-term process. It can look both impressive, what we may have accomplished in 6 years, and then maybe realistic and reassuring to know that in some other areas we have lots more work to do. So, carrying through this institutional transformation, these are some of the questions that we've confronted at Berkeley, and in the questions I'm happy to engage on any of them, as I'm sure that Nick and Rebecca are as well. What's underneath all of them is that at Berkeley, what we had was largely a grassroots initiative that worked its way across the institution with a really broad social base and an explicitly big tent approach. That bottom-up coalition of faculty who knew each other, working together and pouring themselves heart and soul into creating courses, that bottom-up coalition ended up meeting with top-down support. And that is a work in progress too. So what made it work? If I step out to the big picture and look at some lessons for strategy and process, we made the strategic choice, gamble that we wouldn't just do a technical or a broad or a socially aware major. We decided to try to do all three at once. We are further on some paths than others, but for us, it was the right choice. In part, that's because it meant that the values of our program, our major, our minor, our broad engagements across the institutions really matched with the institution's values on its own. And another part of that clearly was, the values of the institution of higher education are the students. They're at the center. And starting from the students rather than from departmental power politics, understanding that we are all here together in their service and making that our touchstone. So those are some reflections on strategy. Briefly on process, I mentioned that we started at the grassroots. It had to meet the top down, though, because resources don't get allocated until you have the mid-level and high-level support. And that's an ongoing lesson for us. We've also learned that there's a mesh that needs to happen between the dedicated faculty at the core and the broad tent, the big tent, the campus-wide reach. And it has to be a both and if it's going to reach to institutional scale. And finally, it's been 6 years to this point. It's a long process. It took a lot of socialization, but we had the time to socialize. And coalition building itself is not a quick process. So if you take those as the lessons of building the undergraduate program, I think it sets us up pretty well for creating a new college level division, essentially reconfiguring the data science, reconfiguring the university around data science. And I'm happy to engage on this as well. If we go back out now to institutional transformation, you see some of the key points highlighted even in our academic senate's response to the proposal for our division. My sense is that the rise of data science in the construction that we've been fortunate enough to pursue it at Berkeley, which is holistic and connected and socially aware and technically strong, is one of the most significant transformations that higher ed needs to undergo, at least in intellectual terms, in our lifetime. So how do you do that? First of all, by recognizing that that's what you're doing. It is an institutional scale transformation, and you need to take cues from what we know about institutional structural transformation and social movements. I put some of my guiding books at the bottom of the slide. I say this for the end. Like, I come from the area of human context and ethics. The idea that a historian would have a voice in data science is still a stretch for many folks, but historians know that who's at the table is critical for making change. And so I try to keep just inviting myself to meetings or setting them up and saying, this is really a coalition that we all need to build together, bringing in the strengths of people who read histories of oppression or social transformations or feminist theory and take a lead from authors of color. This is part of the transformation of our institution in the service of that human, social, natural, STEM, everything discipline that is data science. And if history isn't about the past, as I've learned as a historian now for the last 24 years, if it's a study of the dynamics of human affairs unfolding in time, what we see now here in front of all of us is the capacity to set things on a new course. And so that's been what I feel like really lucky to have a chance to help shape with my colleagues here at Berkeley with their partnership. I do think this is a social movement that has the potential to transform the university. And now I'm hoping that this account of it will be helpful to you. So thank you.
Thank you, Cathryn. We've now, let's start the open mic part of the session. And what I would like to ask people to do is to please chat your question into the chat box, and then we'll call on you in the sequence that we receive your questions. And ideally, we'll have one of the panelists respond to the question and then ask if a second panelist feels like they'd really like to add to the answer, and move on from there to the next question so that we can have plenty of opportunity for everybody to get their questions answered. I noticed maybe while folks are forming their questions that let's look at Matthew Brett, who asks, who's been asking Rebecca about who should be coding. And
it's a great conversation. It's the right conversation. I think it's a smart, that's right. Yeah.
And I wonder if your answer is in some sense impacted by not having a data science major on your campus, and if people are sort of framing the who should be coding from the perspective of, okay, what should a data science major do, as opposed to someone involved in data science. So
yeah.
Rebecca, could you answer that?
Yeah, thanks, Deb. And I want to thank everybody for asking those questions in the chat and starting that, because I think that is a really important conversation. And I do think some of it's terminology and some of it is kind of what your goal is. But so if we think about that data science, so this is my opinion and what Carnegie Mellon has been doing. There's a diverse set of opinions. If you think about that data science life cycle, not everybody is going to be doing all of those steps usually, right? Like in practice, you're going to have specialists and experts. You might have project managers who oversee the whole thing. But, you know, people who are building maybe the visualizations and the analyses, they're not necessarily going to be people who are going to be building the security and the management and the infrastructure. So what a data scientist is, or what a data science major should be, I think that is a really important question. Is a data science, someone who graduates with a data science degree, are they experts at doing every single step in that life cycle? Maybe, maybe not. I don't know. We don't have a data science major because we just kind of think a bunch of the degrees are already doing data science, and it would just be kind of a relabeling. That's really kind of the reason. For us, it's just like terminology. So to the discussion that was happening in the chat, I think a data scientist, and Hadley Wickham got evoked in the chat too. I think a data scientist, you know, would be doing the more technical things and would be doing the coding and would be doing the programming. I just think that when we think about data science courses, data science largely across the university, there are billions of people on this planet who are not going to code and program. I mean, they're going to work other kinds of jobs that support, you know, that interact with people who program and code and the data scientists, right? So I think of data as being the thing that's going to be uniting everybody. And that if we can build data science material and content that supports people who are not going to be coding experts, but need to learn maybe a little bit about coding, which ISLE does, and a lot about data interpretation and how to talk about data and how to write about things and do that sort of stuff, that will train a huge piece of the population. But I would not refer to those as being data scientists at a particular company. So I think that's kind of where, so we use ISLE to help that population, and we also use ISLE to help people who need it to step into data science, right? So not everybody has to start on ISLE, right? We also use ISLE for exec ed all the time, where they bring in people from HR, from like all over their companies who kind of interact with data, but are never going to be coding on the back end ever. And they use ISLE to kind of interact with things and learn how to talk about data. So that's kind of where we're going at with that. But I think the conversation is spot on. What is a data scientist? What does it mean to graduate with a data science degree? Yeah, and then
I think that that distinction that you make there, Rebecca, is really helpful, because I think for the majors, or even kind of someone with a full-blown associate's degree, they're going to need the coding skills. They're going to need to have a pretty kind of solid understanding of not one, but probably two different environments where they can do some comparative contrast. But I think it's really important as you think about those other audiences, the managers, those, you know, I would hope that a student coming out of an ISLE-based course, because I think that's a great environment to allow them to kind of engage, or CodeApp, or some of the other things we've been hearing about.
There's lots of things, yeah.
But I want them to be able to then say, wow, I love this, and then pop into a Data 8 like course.
Sure.
And I worry at times that we've often tracked people so much that they don't have that ability. And so I think kind of keeping those multiple pathways and flexibility as we plan our programs.
And I just want to add, our experience has been that sometimes for some populations, I'm not saying this broadly, but for some subgroups of our students, the cognitive load that is associated with learning the programming syntax tends to dominate, and they don't learn the statistics material as well, right? Like the actual sort of concepts for some groups. That's not for everybody. So we were like, to your point, we're trying to find flexible pathways to help support students where they need support and move into whatever they're going to do afterward, right? Like we want to help them on that, whatever that path is. Yeah. So thank you. Yeah. Thanks for the chat. Yeah.
Yeah. I'm going to skip around a little bit just because it's sort of easier to see some things than others, but Cathryn, there is a question here from David Glimp about very exciting and helpful. Cathryn, where can we go to learn more about your, quote, on-ramp courses for Data 8? And can you speak a little bit about what those on-ramp courses, like how were they envisioned, and what's the difference between them? And it's related to what Rebecca and Nick were just speaking about.
Definitely. And Deb, you may know more about some of the content now that you've taken on that portfolio. So Data 6 builds on a computational thinking class that takes some of the content out of Data 8 and gives people practice with coding before they are trying to learn the inferential content at the same time. And so we had the good fortune of working with a scaffold that Ania Adhikari, one of the code developers of Data 8, had put together with Henry Milner, who had taught it, and really focused the attention on learning the practices and concepts of computational thinking, and then finding ways to swap in data sets and social framing and questions to be asked coming out of social framing very explicitly. So the idea there was to grab students whose interest was in the social world and or who needed to fill a social science breadth requirement and pull them into at least part of what data science does through the deep embedding of questions about inequality, prejudice, allocation of resources. And so that will be piloted for the first time, am I right, Deb, later this summer in this new form? And I think once we've done that pilot, we may be ready to share it out.
Yeah, and in fact, it's going to be piloted in a special course with a limited number of transfer students, underrepresented minority transfer students coming to Berkeley. And so that's going to be the pilot, and then hopefully sometime next year or the year after, we'll have it offered as a regular course during the academic year.
Data 4 is a little bit less, it will first be taught next spring 2021, and it comes out of the work of our human context and ethics team, who are taking some of the things that they find draw in students at the junior senior level and bring it down to a broadly accessible level and say one of the routes into data science is thinking through questions of justice and race in American society. And we're hoping that this will both message our deep commitment to inclusivity through the angle of equity, and also prepare students who go into Data 8, if they choose, with a set of both humanistic and social science concepts for thinking deeply about, I mean, how shall I say it? I go around to data science conference saying every conversation about data science in the United States is a conversation about race, because every conversation about American society is underneath a conversation about race, because structural racism is embedded. So how can we make that understanding of our social world an entry point into data science instead of an implicit exclusion?
Great, thanks, Cathryn. And just to add to that, there is the thought of having Data 2. So we'll have 2, 4, 6, 8, where 2 will be focused on on the human context and ethics and statistics, and less so on the computational piece, which again goes to what Rebecca and Nick were talking about. I'd like to turn.
Great idea. I just want to say that sounds amazing. I'd love to hear more about that. Once you guys get that going, that'd be great to hear about. Yep.
I'd like to turn and give this one to Nick, and someone else can follow on. Sorry, they keep moving off the screen. I'd love to hear how some of the speakers and their institutions have tackled the competing interests of depth and the prerequisites, math, probability, machine learning, and all the other technical pieces, and yet keeping the curriculum flexible to handle different students' needs, as was discussed.
This is a concern near and dear to my heart, Deb, and I see Rebecca nodding and others. Typically, you would take CS0, CS1, CS2, CS3, and then you start to get to do some interesting things with data. And that's just not going to work. On the statistics side, it's perhaps even worse. Pre-calc, Calc 1, Calc 2, Calc 3, linear algebra, probability, traditional inference on boring p-values, and then you can start to do interesting things. And so at some level, that we need to blow it up. George Cobb, may he rest in peace, talked about how, it's maybe like a California real estate metaphor where the ground is really valuable, but we just need to tear down everything that's on it and start again. I do think there are important mathematical, statistical, and computational foundations that are needed for those, particularly those minoring or majoring. I don't think you can or should be teaching kind of stuff without that kind of foundation, but I think we need to develop ways of doing that don't have a 5-semester stretch of linear prerequisites. And so I think we're starting to see a lot of movement in this regard. One, encouraging thing is the amount of statistics we're now seeing in middle school and high school. The fact that in, Common Core states and many others, the students are now doing the equivalent of a 2-sample t-test in high school, not the AP statistics. We've got incredible things going on in the CS for All and other K-12 computer science initiatives. And I think the tools there, kind of some of the bootstrap approach to teaching data science in different contexts. I think the code app that I mentioned in the those are going to be tools that allow people to start to engage with the aspects of coding, these other foundational things. And then I think we just need to be able to respond in universities with courses that would give people the appropriate, say, mathematical foundation without all those courses. And then if they got really excited about math, they could take other math courses. Look, here's linear algebra. But we just can't keep hiding our courses beyond those long lists. Deb, are you muted?
Oh, sorry, I had a lag, and every time I'd hit unmute, I'd hit it twice. And okay, thanks, Nick. Rebecca, there was a much earlier question from Pamela Reynolds about the sort of capstone thing that you're talking about, and asking about vertical integration. And are you having PhD, masters, and undergraduate students all working on the same projects? And I'd like to throw in one more question for you to answer while you're answering that one. And that's around the data that the students are working on and privacy issues. And a lot of times when we put in so much effort into helping work on a problem, one, we'd like to use the data again. And is that an issue? And the other is sometimes the partners don't actually really want to share their data at all, even with the people that they want to have working on the project.
So I think, so I'll do that in 2 parts. So the first part is, I think much like what you heard from Nick with the, I believe you called them SDS fellows, and then what you're also hearing from Cathryn and Deb, et cetera, in the Data 8 world where you have all these students helping, we are doing similar things. And I'm also going to tie this to a question in the chat that was talking about how dispiriting it is to hear at some places faculty are really into this, but what do you do if you're at a university or an institution where faculty are not as committed to this idea? We hear you. I live that life every day. Every day we've got to convince people to do stuff. But I think drawing on the students is incredibly helpful. And if you can build anything vertically integrated, it is going to be, I think it's going to be a big boon. It's going to be a big win for everybody. The students also learn how to supervise, etc. So what we do is we're vertically integrated throughout all of our programs. Like the freshman early research courses have senior undergraduate TAs that help them. And then, okay, so Kenneth Arnold, I hear you. I'm gonna get you connected. Don't worry, I'm with you. Hang on. And then through the courses, there are just kind of layers of TAs that come up, and the same thing happens on the research side. So a project team of undergraduates would have a PhD DSI fellow. That's what we call them, DSI fellows. And then it would also, all those project groups also meet together every once in a while. So the DSI fellows meet, the faculty meet. So there's kind of this vertical integrated structure. One of the things, and the PhD students love it because we pay them. That's important. We pay them. But they also get supervisory experience, and they get to work with industries, and they have on their resume, like, I supervised, this data science project for this company, doing this stuff. It's a very unusual experience for them. Even if they're heading into academia, having that kind of supervisory experience is a real positive. The master students tend to not be as integrated into those different layers. And I was thinking about that while we were talking. And I think it's because the master's curriculum tends to be pulled out a little bit more, or they have kind of their own system. But we would do the vertical integration similarly. We would have PhD and master students and undergrads. So that's how we handle that. With respect to faculty, this is going to get into the privacy stuff, Deb. With respect to faculty commitment, I have found that one of the best ways to get faculty to help supervise these data science projects during the year is by paying for their summer research time. So they might do like a certain amount of data science supervising, and that equates to whatever works in your institution, 1 month of summer support. So I'll have faculty members who just supervise projects, and it's kind of like they bought their summers for free and they can work on whatever they want. Like, it's not a grant, it's almost just like discretionary. So that's how we kind of get faculty to sort of help with that. So part two, okay, the privacy and getting people involved. That very much depends on the project and the partner. We have people who are comfortable giving us Excel spreadsheets, and we have that they can keep on their laptops, the students' laptops. We run that all the way through. The students have to have accounts that they log into the outside partner servers, and they're only allowed to run code and analyze things on the outside partner servers. My colleague, Peter Freeman, who is an associate teaching professor at Carnegie Mellon, he and I kind of like to call this just-in-time statistical computing, which means that the students, as part of this experience, are having to learn different computing infrastructures as needed for the project. So sometimes we set up a server in the department, sometimes the partner does it for us, sometimes they've given us non-proprietary stuff, okay, that we have. It's very dependent. All of that is negotiated ahead of time as part of the educational project agreement. Every educational project agreement has a confidentiality clause and an NDA associated with it, but it's all negotiated ahead of time. And then the companies, the partners, well, it depends on who they are. We don't charge, for example, nonprofit social services type of thing, but there is a fee associated with participating. But like, nobody is going to Tahiti on this. This is not like a huge fee. It's more like a cover the costs of supervising the projects and our like legal stuff. Like, it's not a fundraiser by any means. So there's that.
Great,
Yeah.
Thank you.
Yep.
The next question is will be directed. I think I would like to hear both from Cathryn and Nick on this, and this is about the ADSA organization and the ASA, and sort of where do you see a good home for broad-based data science building community. And Cathryn, why don't you start? And then I've asked Nick also, because Nick's a tried and true statistician, and so he's very connected with the ASA and has done a lot of work for the ASA. So I'd like to hear his perspective on it too.
Okay, sure. I'll give my keys, and you all can give your alternative perspectives. I feel very welcome at the ADSA. I wouldn't feel welcome in any of the other technical professional organizations. So if data science is meant to include people who are not technical, whether they're in application domains or HCE areas, then I think we need a new organization. So ADSA is the one that's there. I give them a hard time too. They tend to have, repeated panels on ethics where I'm the person there, and I'm like, there's more of us. Invite Sophia. Don't just go to the people you know. And so I think this sort of opening up of the field is one of the moves I want to advocate for. But existing organizations can change too. So maybe Nick has a perspective he wants to share too.
Yeah, I think I have a similar kind of sense to that, Cathryn. I know that there are, large and active initiatives within organizations like the Association for Computing Machinery, within the ASA, within, even organizations like the Institute for Mathematical Statistics, and the math organizations. And again, people see that data science is important to engage with, and that it's at some level different, but kind of like a big part of what they're doing. I think what I really like about ADSA, and I'm serving on the planning committee for their upcoming annual meeting, and I've been involved in some other initiatives, is that it really does have a kind of a different across the professions kind of approach to it. It has really been focused, I think, historically coming out of the more Sloan environments. And I think what I've learned from the more Sloan environments are there's really interesting things happening at these research-wanted universities where a ton of money got dropped to try to create new structures, create spaces and opportunities for those kind of interdisciplinary connections that you're discussing. I still think there's going to be a role for kind of professional organizations. I think degree programs will be multifaceted. I think the roundtable conversations on what a data science PhD program look like were interesting, in part that I think there's still going to be value for computer science, statistics, and also kind of digital humanities PhDs, as well as potentially data science PhDs. But I think that the message you described there, of Cathryn, of intentionally creating structures that are welcoming, it's the same kind of strategies we need to ensure that our classrooms are inclusive and welcoming. And if we just take the kind of standard kind of approach that was put together, as you've noted in some of the commentaries, kind of structural filters are problematic. And so we need to kind of be able to kind of ensure that there are structures there. And I think for me, it's kind of like have multiple associations that are out there that can really meet the needs and kind of work together to kind of move forward with data science. So I'm a proud life member of the American Statistical Association. I'm a member of the ACM, and I'm also active with ADSA because I see them all as different kind of angles on a very, very interesting and multifaceted problem.
Great. Thanks, Nick. Rebecca, I'd like to ask you the next question, and you touched on this in your talk, and it might be just really too big a question, and it's about data science as a research field. And I sort of see your ISLE project as kind of getting at that, and maybe you can kick it off, and then we'll see if Cathryn or Nick want to chime in. But data science in some sense has grown out of statistics, but that's its own research field, and computer science as well. And so what's different, and what makes or might make, or is it yet or going to be, a research field?
Yeah, I think that's what, when data science exploded, and I'm going to be, I think this might be being recorded, so we'll see how many provosts and deans hear what I'm going to say next. But I think that when data science exploded, everyone got like super stoked about creating hundreds of master's degrees with stuff that already existed, slapped a title on it, let's cash in, let's make some money. And that was kind of the first wave because it was so popular. And of course, you know, we need money to run these universities. And so I don't know if I really mean it as a criticism, but I don't think anyone was really thinking through kind of what these programs and degrees should look like. So that's what we're doing now. So that's great. But what we haven't really seen is, okay, let me go back one more. So that was the first thing that people did, and universities and institutes also cluster hired data science faculty, like left and right. People were like, we'll tackle data science we'll hire faculty who are half in some institute and half in a department, or, you know, some variation of that. And then what happened was people were like, well, how do you get tenure in this? Like, what does it mean to be a data science faculty member? Like, what does that actually mean? Because no one had even really kind of thought about it. So we're throwing together things, but what does it actually mean to do research in data science? Well, you know, computer science, you know, whatever 70 years ago was not really a full-fledged field. Now it would be, everyone thinks, oh yeah, of course you get a PhD in computer science. So we'll see what happens with data science. But I think the idea of how to research things like how to best do data science, what is the optimal way to think about a data science workflow. There was a really interesting paper that came out, many analysts, one data set a couple of years ago, where the same data set and the same research question was given to 29 different teams of analysts, trained analysts. These are people who theoretically knew very much what they were doing. And you should see the breadth and variation of the results that came out of it. And the point was, when we're thinking about reproducibility and replicability and analyses and workflows, that last final decision you make at the end, is this significant? It's not just about documenting your code. It's about every single choice, every single possible path. We've seen results of studies now that if you show people histograms versus box plots, the final answer is different. I mean, that's just a graph choice. So that's one thing. Like every data analysis you do is one of an observation from a population of data analyses. And that branching structure is incredibly complex. So I think that's one interesting research area. Another area that's coming up a lot for us at Carnegie Mellon is which sets of experiments to run and in which sequence, right? So thinking about, like, I have incredibly complicated experiments. If you're working with Boeing, you know, we're not going to be like remaking planes all the time, right? Like, how can you use data science? How can you research on incorporating variation in the sequential experimentation? That's a big thing. Another thing that people are doing research on with us is thinking about what kinds of guarantees that you can get, sort of theoretical optimality guarantees out of these black box algorithms. What kind of performance can you try to guarantee? So that's more the theoretical side. But I think those are kind of the main things that we're doing. With the IEL stuff, we're hoping, I mean, we're trying to leverage it so people can do data science, right? That's part of it. There's an education aspect. And on the research side, and then I'll stop, we're trying to figure out how to optimize the best way to do this. What are people actually doing when they're looking at data? It turns out we have no idea. What kinds of decisions are they making? Do they write things first? Do they click around? How do they build models? We don't actually know when you just look at the code that turns in at the end. What's the process of how they actually built this? So we're doing a lot of research studies. And of course, I didn't talk about it today, but I'm happy to talk to any university that's listening today, school, et cetera, about the type of research projects we're doing on IEL. And even if you don't use IEL in your classes, if you'd like to participate on the research side of IEL, we'd love to do it. We're generating really rich, complex data sets on how students are working with data. So that's kind of what we're thinking about.
Thanks. Before I turn it to Cathryn, I imagine Cathryn might have a very different answer. So I'd like to hear your thoughts, Cathryn. But before we do, I just want to add to something that Rebecca said, and it's a shout out to Fernando Perez and to our Markdown folks. Is like, I would really like to see something more than a workflow that's linear. And I've talked.
It's not linear. Nothing's linear. Yeah.
A few times, but as you said, it's like your example of choose your own adventure. Yeah, exactly. It would be great to be able to figure out how to capture that and how to also as a learning process for students to learn how successful data analysts think, is to have an annotated document that is more of a tree or something really complex than the linear document where we're currently at. Okay, Cathryn, on to you. Oh, you're on mute.
Sorry, I wanted to pass on this one because I'm having some audio problems. I'd rather listen to people talk than to answer, if that's all right.
Okay, for this question in particular. Yeah, Nick, do you have something you'd like to add?
No, I'm all set at this point.
Okay, great. My next question is not on this list, and it goes to Nick. Cathryn and I the other day were talking about diversity and inclusion, and we started thinking about the examples that are used in Data 8. And what struck me was your comparison of the Little Women with the, Emily Dickinson, and then we're like, what kind of initial sets of examples would really reach out to a broad set of students? And we weren't sure that Little Women did. And so I'm curious if you have thoughts about that, and if you're thinking about not of equity and inclusion as includes also the kinds of data sets that you analyze, as well as trying to create an environment that's welcoming to all students.
Deb, I think those are really important questions, and there's so much I really like about the Data 8 approach. But again, some of these questions about how best to engage with a broad set of students, I think that's both an area of research and an area where we can be doing much better. It was interesting looking at the advanced lab yesterday, which is focused on murder rates from 1971 through 73. And again, that's interesting. That's previous to the parents of the kids. Again, this is, and also again, what's the message that's being brought forward from that? I had the opportunity, during the kind of the Black STEM initiative a couple of weeks back, of taking a day of reading and reflecting, and I was looking at data sets of police reform, and to try to think about how to structure kind of examples for courses that might be more relevant to some of the questions that we're facing as a society. Not in a partisan way, but to kind of really be thinking about, can information be brought forward in those kinds of ways? And it's hard. There's a lot of kind of challenges in making sure that things are accessible, that there's sufficient context, that there's kind of structures for faculty to be able to bring those forward in a way, because I think it's important when we think about data science that we're wrestling with important issues. The astronomers are dealing with orders of magnitude and kind of all these, the biologists are dealing with DNA. Historically, statisticians have dealt with the colors of M&Ms, but we know that there's much more power for these kind of areas. But with that, and again, I come back to some of Cathryn's points, we need to be able to do those in a way that kind of describe the historical context, the bigger issues. We can't just kind of like drop in an example. Oh, here's sexual assault data. Let's start doing a comparison of these two groups. So I think it's your point is really, really important, Deb. Like, what are going to be those examples? How do we keep them timely? And how do we also ensure that they're taught in a way that doesn't reinforce the biases and kind of create another exclusionary environment? So I'm feeling like the more I work up on this, the less I know, but I know that there's expertise and a lot of people working in various realms to really kind of come up with environments for us to be able to teach the important issues that our students need to be able to go out into the world to solve.
Great. Rebecca, did you want to add anything, or Cathryn, to that? Or
well, I thought he said that extremely well. Cathryn, do you want to add something to that?
I'll try. Sorry for this.
Yeah, sure, yeah.
Because data science with data on humans is about data from the past. We all have learned over the last, 5 years, if we didn't know before, that if we weren't cognizant of where the data came from a society riven by structural disadvantage, that we're just going to reproduce it. And because we're training students whose skills are transferable from astrophysics into working in tech companies on human data. I don't think we can afford to give ourselves a pass by not acknowledging that these human issues are at the very center of our field for our students who will have 30-year careers after they graduate. So it seems like it's a monumental challenge, but I think we're ready to take it on.
And then I would just add that looking forward, I mean, I think Cathryn's exactly right about thinking about what's happening with data in the past, but looking forward, really every single person has the right to make informed decisions about their own lives, their own choices, et cetera, using correct data and information and being able to interpret that, et cetera. So I really think of, we've had this conversation over in the chat, data acumen, data literacy, this is slightly different, but whatever you want to call it, this to me is a fundamental class that should be not just general education in every college, community college, 2-4-year, whatever curriculum. But I mean, we need it down. I want my 4-year-old to be able to start thinking about data, right? And in an age appropriate way, of course. But if we are not increasing the data sense of everyone, then data is very much going to divide us into the haves and the have-nots. People who are not able to make informed decisions using the information, or don't have access to data about their lives, about their communities, and so can't make decisions. It's gonna end up just causing these rifts and these divisions we see now to be even bigger, right? And data should be uniting us, right? So that's kind of how I think of it for the moving to the future.
Thank you all. I'm looking at the time, and I'm going to give you a heads up. I'm going to talk for a minute, and then I'd like you each to take a minute to have some kind of concluding statement. There's been some things in the chat about mathematics, and so I thought I'd just chime in while you guys put your thoughts together. I'd like to say that I think there is some kind of movement in terms of what kind of mathematics is really needed for doing data science, and that's at all levels. I'd like to give a few examples. In the state of California, there are area A, B, C, which are sort of minimal requirements to get into a University of California campus. And I'm on a committee right now that's actually revisiting the Area C math requirement, and we're looking at including data science at the high school level as an alternative to algebra 2 and calculus and that sort of thing. In addition, I'll put out a shout out for tomorrow. The community, there are going to be a couple of things about the California strategy, including one to try and hear from the community colleges about how best can we help you to bring data science into the 2-year college. Nick mentioned 3 reasons for AA degrees or transferring and employees. And the last thing that I'd like to mention is that we are starting on a project with the math department to create a new course in terms of math for data science, which would allow students to compress some of the mathematics prerequisites for the current data science major and not need to take 4 calculus and linear algebra, et cetera, courses before they can take their upper division data science courses. That's still a road ahead of us, and I know other institutions are already well down that road, but that's a few things for thought. And now, why don't we take it in the same order that the initial speakers were in? I'll ask Nick, followed by Rebecca, followed by Cathryn. We got 3 minutes left. You each get a minute.
So thank you, Deb, for moderating with what I thought was a great session, and I loved how the connections between all the speakers. I think the points you make about the math curriculum and ways to kind of re-envision that, I'm glad to hear about that course being developed at Berkeley. I know that there's a lot of initiatives happening now, kind of looking at the junior year of high school through the junior year of college, and to try to make that pathway much more straightforward. There are folks at the Dana Center at the University of Texas at Austin that have been really doing some innovative approaches to that. I think there are other approaches of having co-requisites and other supports and scaffolding. We know that it's a scandalous fraction of students, particularly students of color and women, who are kind of pushed out of the calculus pipeline. Historically, Cathryn had alluded to that, described some of the structures for it in that engineering book in the chat. But I think that if we can kind of envision some of those approaches with kind of catch up and other ways to kind of engage, people can get the needed math framework and foundation there. And that's an area where I think we need to be working really hard.
Great. Thanks, Nick. Rebecca?
I think I mostly want to say thank you to the community that participated on this panel. This was an incredibly rich discussion, both here on the live video and then over in the chat. This might be one of the richest discussions I've ever participated in on a chat. And what I think that shows is the commitment and the drive and the dedication that this community has to try to leverage data science as an empowering force versus a division. I want to just echo one more time something that we're talking about over in the chat, just that we should be using data to empower people.
Dang. That's a great end of a sentence, Rebecca. We'll stick with that. Thank you. How about you, Cathryn?
I wish I could finish Rebecca's sentence for her, because she's absolutely right. This is about bringing the things that we as educators were lucky enough to learn in each of the ways we can, with our different skills and our different backgrounds, to the broadest population of students. And so it's really exciting to have all of these different ways on view. And then, there's no single royal road to this. And thankfully, we have a strong collaborative dialogic community where we're each learning from each other. And I really appreciate Deb's facilitation of that conversation.
You're welcome. Rebecca's back.
That was crazy. I wasn't even touching the computer and the Teams just crashed. I was like, wild. It was like,
you wanted to empower people.
Empower people, done. Okay, so I apologize to everyone for that. That was very bizarre. But just to echo that, I really appreciate this community. I think the more we work together and talk together, the better things are going to be. Let's use data science and data to empower everyone versus divide. And I think we're off to a really great start. I think we're asking the right questions, and that's the hardest part. Let's get to the right questions, and we'll do the hard work, and we'll get there. And I'm still not touching the computer, so I'll let you.
Thank you to our panelists. Thank you to the audience. A lot of great questions and conversations, and lots of things will be posted in terms of slides, and from the chat we'll pull books and other links that people posted. Thanks a lot. We'll see you in the next meeting. Bye.